Hello everyone, and welcome back to the channel. Today we are traveling deep into the mountains of Guizhou, China, a place where roads do not simply cross the land, they fly above it. This is the story of the Huajiang Grand Canyon Bridge, one of the most extreme suspension bridge projects on Earth.
A bridge built across a terrifying canyon, above the Beipan River, surrounded by steep karst cliffs.
Before we begin, make sure to subscribe to the channel, turn on notifications, and follow us for more incredible engineering stories from around the world.
Because what you are about to see is not just a bridge, it is a battle between human ambition, mountain terrain, and gravity itself.
The Huajiang Grand Canyon Bridge was designed for one purpose: to connect roads across a canyon that once seemed almost impossible to cross.
In this part of Guizhou, the landscape is beautiful but brutal. The mountains rise sharply, the valleys cut deep into the earth. The cliffs are steep, unstable, and difficult to reach. Building a normal highway here would mean endless curves, dangerous mountain roads.
Before we begin, make sure to subscribe to the channel, turn on notifications, and follow us for more incredible engineering stories from around the world.
So engineers chose a different solution. Instead of going around the canyon, they would cross directly over it. But to do that, they needed to build a suspension bridge at an almost unreal height. A bridge with two enormous, massive anchorages buried into rock, thick main cables curving over the towers, vertical hanger cables dropping down from above,
and a deep steel truss deck hanging in open air. No center pier in the gorge, no support from the canyon floor.
Only towers, cables, steel, concrete, and precision. The first stage was not dramatic, but it was absolutely essential: surveying the mountain. Before concrete could be poured, before steel could be lifted, engineers had to understand the canyon. Survey teams mapped the cliffs, checked the rock layers, measured the slopes, and studied wind behavior inside the valley. In a place like this, one wrong assumption could affect the whole bridge. Then came access roads. Construction crews carved temporary roads into the mountain slope so machines, workers, concrete, steel, and cranes could reach the tower sites. These roads were not part of the final bridge, but without them, nothing else could happen. Next, the foundations began. On both sides of the canyon, workers excavated deep into the steep slopes to create stable tower bases. These foundations had to carry the future weight of the towers, the cables, the deck, and the moving traffic. Reinforcement cages were placed, concrete was poured in stages, and the bases slowly became massive structural platforms locked into the mountain. Behind each tower, another critical system was built: the mountain anchorages. These are the hidden giants of a suspension bridge. The main cables do not simply hang in the air. They must be pulled back and locked into something powerful enough to resist enormous tension. At Huajiang, that meant building huge concrete anchor blocks embedded into the rock slopes, with cable entry chambers and channels prepared for the future main cable system. Only after the foundations and anchorages were ready could the towers rise. The towers were built lift by lift using climbing formwork. Each section was reinforced, poured with concrete, cured, checked, and then the formwork climbed higher. Slowly, the tower legs grew above the canyon. At first, they looked like separate vertical concrete shafts. Then lower crossbeams connected the tower legs together, giving each tower more stability.
Falsework supported these crossbeams during construction, and once the concrete was strong enough, the temporary supports were removed.
The towers continued rising. More lifts were poured. Higher platforms were added. Stair towers and temporary access systems climbed upward with the structure. Then came the upper crossbeams, another major step. Workers placed embedded sleeves, temporary brackets, starter segments,
dense reinforcement, and formwork between the tower legs. Concrete was poured at high elevation, cured, stripped, inspected,
and finally the falsework was removed. Now the towers were no longer just vertical legs. They had become strong, connected frames ready to support the cable system. But a suspension bridge depends on one of its most... At the top of each tower, crews formed concrete saddle pedestals. These had to be extremely precise. The future main cables would pass over the towers through steel saddles, and every millimeter mattered. The concrete surfaces were ground, leveled, checked, fitted with anchor bolts, base plates, grout, and finally the massive curved steel saddles were lifted into place.
These saddles would guide the main suspension cables over the towers. Now the bridge had towers, anchorages, and saddles.
But still, nothing crossed the canyon. The next stage began with something surprisingly small. A pilot rope. A light rope was pulled from one anchorage, up to the first tower saddle, across the canyon, over the second tower saddle, and down into the opposite anchorage. This first line was thin compared to the final cables, but it was the beginning of the bridge reaching across open air. Using that pilot rope, crews pulled stronger ropes. Then came the catwalk. A catwalk is a temporary suspended walkway used by workers during cable construction. Support ropes were stretched across the canyon. Mesh panels were installed. Hand ropes and safety netting were added. And eventually, a narrow working path connected both sides of the gorge. Imagine walking on a temporary metal path suspended thousands of feet above a river, surrounded by wind, mist, cliffs, and open sky. That was the workplace for the cable crews. Then the main cables began. Unlike what many people imagine, the main cables were not lifted as one giant piece. They were built from many individual high-strength wires.
Wire after wire was pulled across the canyon, over the saddles, and into the anchorages. Slowly, the open wire bundles grew thicker. First one main cable alignment, then the second.
Once enough wires were in place, the bundles were compacted into round cable shapes.
Hydraulic machines squeezed the wires together. Temporary ties held them tight. And then wrapping machines applied protective wire and corrosion coating. Now the bridge had its two great parabolic main cables, but the deck still did not exist. Next came the cable bands. These heavy steel clamps were installed at regular intervals along the main cable.
Each band would become a connection point for vertical hanger cables. Crews bolted the band halves around the wrapped cables,
Tightened them carefully, checked spacing, and prepared them for the hanger system. Then the vertical hangers were installed. One by one, ropes dropped from the cable bands toward the empty space where the bridge deck would later hang. At this stage, the bridge finally began to look like a suspension bridge. Towers, main cables, and rows of vertical hangers floating over the canyon. Now came the steel truss deck. Deep steel truss segments were assembled in mountainside yards. Each segment contained main truss members, crossbeams, lower bracing, and lifting points. Cranes and cableway systems lifted these segments into position beneath the hangers. The first segments were installed near the towers. Then more were added.
From both sides, the suspended steel truss deck grew outward toward the center of the span.
Every segment had to be aligned, bolted, connected to hanger cables, and stabilized before the next one could be installed. As the two deck arms approached each other, a final gap remained at mid-span. This was one of the most important moments in the entire project.
The final closure segment was lifted into the gap. Crews adjusted the geometry, checked the temperature movement, and aligned the steel chords, inserted bolts, and locked the two halves together.
At that moment, the suspended deck became continuous across the canyon. The impossible road was finally connected. But the bridge was not ready for traffic yet. Steel deck panels had to be installed across the truss.
Joints were welded and bolted. Temporary catwalks were removed. Waterproofing was applied.
Asphalt was paved from both sides toward the center. Barriers, guardrails, drainage systems, expansion joints, lighting poles,
Sensors and electrical systems were installed. Then came testing.
Before ordinary vehicles could use the bridge, engineers needed proof.
heavy test trucks were positioned on the deck. Sensors measured cable sag, hanger movement, tower response, deck deflection,
vibration, and expansion joint behavior. First came static load testing.
Then, dynamic load testing. Trucks moved across the span at controlled speeds.
Engineers watched the data. Every cable, hanger, truss joint, and tower response had to confirm that the bridge was behaving exactly as designed. Only after those tests could the bridge move from construction to operation. The first controlled vehicles entered the bridge slowly. Then traffic increased. Finally, the Huajiang Grand Canyon Bridge became what it was always meant to be, a road across the sky. A bridge where cars and trucks moved smoothly above a canyon that once forced travelers to take long, difficult mountain routes.
A bridge held by towers, anchorages, saddles, main cables hangers, and a deep steel truss deck.
A bridge with no central pier in the gorge. A bridge that turns one of the most difficult landscapes in China into a direct connection.
What makes this project so incredible is not just its height. It is the sequence.
Every piece had to happen in the right order. Foundations before towers. Towers before saddles.
Saddles before pilot ropes. Pilot ropes before catwalks. Catwalks before main cables.
Main cables before hangers. Hangers before the truss deck. Deck before pavement. Pavement before testing.
Testing before traffic. This is the hidden logic behind every great mega project.
From far away, the final bridge looks simple, a graceful line crossing a canyon. But inside that line is years of surveying, excavation,
Concrete, steel, cable spinning, precision lifting, testing, and human courage.
And that is why the Huajiang Grand Canyon Bridge is more than a road. It is a statement that even in the steepest mountains, above the deepest valleys, engineering can create a path where no path seemed possible. If you enjoyed this journey inside one of the world's most extreme bridge projects, don't forget to subscribe, like the video,
and follow the channel for more cinematic stories about the greatest engineering achievements on Earth. Thank you for watching.
and I'll see you in the next incredible build.